So, you've installed Go on your system. Now what? To start working with Go code, either your own code or packages provided by third parties, you must create a workspace. A workspace is a directory hierarchy that contains Go source code and the package objects and command binaries that the compiler produces from that source code. You can create a workspace anywhere on your system. Let's create a workspace now in a directory named Go code. And to tell the Go tool about that workspace, set the GOPATH environment variable. Source code resides in the src directory of your workspace. Let's make a directory called src, and inside it we'll create a namespace, a unique base path inside which all of your Go code will reside. I use the base path of my GitHub account, github.com/nf, but you should choose something unique to avoid naming collisions. Now we're ready to write a program. We'll start with a hello world command. So let's create the directory hello inside the namespace, and inside that directory, create a file named hello.go. Inside hello.go, we'll put the standard hello world Go program. Note that this code belongs to package main. This is a convention that tells the Go tool to produce an executable command instead of a package object that would be imported by other code. Exiting the editor, we can now use the Go tool to build and install that binary. If the Go tool produces no output, that means the command was a success. As they say, no news is good news. But where is my hello program? The Go tool has installed it to the bin directory inside the workspace. Let's take a look. Ah, there it is. Let's see if it works. Great! We just wrote, built, and executed our first Go program. Since we're going to install and run a bunch of Go programs in the foreseeable future, it makes sense to add the bin directory to our system path. So now I can just type hello to run the hello world program. Now let's create a package. Packages are just like commands, except that they can be imported by other packages and have a package name other than main. We'll start with a simple string handling package, so let's create a directory inside the namespace called string. And in the directory, we'll create a string.go file containing a simple function that reverses a string. Note that the reverse function begins with a capital R. That means that the function is exported and can be used by other packages. If it began with a lowercase letter, it would be unexported and therefore unavailable to other packages. Exiting the editor, I can check that my function compiles by running go build. Again, no news is good news. But where did the object file go? When used on Go packages, go build just builds the code and throws away the output. To make the string package available to other code, we need to install the package object to our workspace with go install. Now we can find the package object inside the pkg directory of our workspace. Ah, there it is. Now let's use this string package from our hello program. Now if we compile and run the hello command, we should see the greeting written backwards. Very good. The Go tool has located the github.com/nf/string package and used that when compiling and linking the hello program. But we're not done yet. Is there a bug in our code somewhere? There could be, but we'll never know because, that's right, we don't have any tests. Let's write a test for the string package's reverse function to make sure it's correct. The tests for a package live in that package's directory in files that end in _test. Let's create a file named string_test.go inside the string directory. Using the testing package, we'll write a quick table-driven test for the reverse function. Note that the string_test.go file is also part of package string, but it won't be compiled into the package when you run go install or go build. However, when we run go test, the Go tool will compile all of the package files, including the tests, and synthesize a test harness that runs any functions beginning with test with a capital T. Let's run the tests now. Uh-oh, looks like there's a bug. It's clear to me from the test results that the reverse function doesn't handle Unicode characters properly. Let's take a look at the code. I see the problem. At the top of the function, we converted the string into a slice of bytes, when really what we should have done is converted it into a slice of runes. Runes are what Go programmers call Unicode code points. By changing the conversion to use a slice of runes instead of a slice of bytes, we make the loop iterate over distinct Unicode code points instead of bytes. That way it should handle any well-formed UTF-8 string we can throw at it. Now let's run our tests again to make sure our code is correct. Hooray, the test passes. And better still, now you know the basics of the Go tool, workspaces, packages, commands, and tests. To learn more about Go, visit golang.org. Happy hacking!